So in the triangle OAB, you know that O to A is A. So let's do that. And we know that O to B is B. We also know that P divides OA in a ratio of 3 to 2. So let's put P over here, where it's at a ratio of 3 to 2. And Q divides OB in a ratio of 3 to 2. Let's put Q over here, and this is 3 to 2. Show that PQ is parallel to AB. So P to Q is parallel to A to Q. Right. So when two vectors are parallel to one another, that means they are multiples of one another. So let's find out what A to B is and P to Q is and see if they are multiples of one another. So A to B, in order to get from A to B, I'm going to go from A to O and then from O to B. So A to O is minus A plus O to B, which is B. And then to get from P to Q, right? So from P to Q, I'm going to go from P to O plus O to Q. And P to O, well, that's the 3 part of the 3 to 2 ratio. Because it's split into a 3 to 2 ratio, it's split into 5 portions. And this is the 3 part. And I'm going back from P to O, so that's going to be negative 3/5 A. And then from O to Q, again, that's the 3 out of 5 portion of O to B, and that was B. Okay, so we've got our A to B and our P to Q. And now I have to show that they are multiples of one another. Well, if I factorize out a 3 over 5 from P to Q, then you get minus A plus B remaining inside the brackets, which is just A to B. So we've shown that P to Q is 3/5 of A to B. So they are multiples of one another, hence they're parallel. And the last part says, that was part A, and then part B says that given that A to B is 10 centimeters in length, find the length of P to Q. Well, we've just shown that P to Q is 3/5 of A to B, and that carries through on the magnitude side. So the magnitude of P to Q is going to be 3/5 of the magnitude of A to B. And so therefore it's 3/5 of 10, which is just 6 centimeters.